Hi, my name is Benjamin Olanimi. Welcome to my final presentation for Intro to GPU Programming. The project will be centered around computer vision, specifically running through Hello World AI and setting up the Jetson Nano, examining a pre-trained model using SSD MobileNet V2, and then training a custom model to find a specific bear that my daughters leave laying about. Finally, we'll do a comparative analysis of the pre-trained model versus the custom trained model. As part of the Jetson project, NVIDIA has provided a Jetson Inference GitHub repository with various examples of how to get started on various types of computer vision elements, segmentation, object detection, and image recognition. For this project, we'll of course be focusing on object detection within the frame. It provides a pretty good walkthrough, including videos on how to set up the Jetson to use TensorRT and PyTorch. Now that we've installed everything on the Jetson Nano, we can start with our first run, which is the SSD mobile one. And as you can see, every one of my test animals here registers as a teddy bear. You can tell that it's picking up my arm there as a person, along with the confidence ratios. You'll also notice that the frames per second is hovering around 80, which is good enough for real-time computer vision. The pre-trained model is trained on a variety of objects to detect. For reference, this guy right here is the teddy bear of interest for the custom object detection that we'll be pursuing later in the project. His name is Little Mr. Bear, so he'll be denoted as such in the labels for the model. My first iteration was successful in achieving a high confidence interval for Little Mr. Bear. I observed that it did not generate a false positive on identifying the dog. There were several instances of false positives in the first iteration of training. As you can see in this screenshot, it incorrectly identifies the other bear, which has a similar texture and color as Little Mr. Bear. It also keyed in on my forearm as part of it. This led me to believe that my dataset for training was incomplete. One of the things that I learned along the way here is that when training a model for computer vision, the dataset is really the determining factor. The verbosity of the dataset really impacts how accurate of a model you can make. In an attempt to alleviate the minor false positives that were observed from iteration 1, my second iteration of training, I prepared a training set that focused on the eyes and the nose of Mr. Bear. Fortunately, this didn't yield any fruit, as we couldn't achieve a confidence threshold of greater than 30%, and there were a ton of false positives on the other animals and false negatives on Mr. Bear himself. So I chose to abandon that approach. The third iteration, I chose to make an exorbitantly large data set, comprised of about 500 pictures, multiple orientations. This allowed for a remarkably resilient model that was able to detect based on change in distance, rotation, orientation. Overall, I was very happy with the performance of this model. This reinforces my previous assumption that the size of the dataset affects the accuracy. Running both at the same time was a little bit challenging, but I eventually found a solution. So you can see here on the bottom view the pre-trained model, custom trained model. See that the pre-trained model keys in on the chair in the background, myself as the person, and has trouble identifying little Mr. Bear as a teddy bear, and he's laying on his face. In the upright position, the pre-trained model does correctly identify little Mr. Bear as a teddy bear. My model also identifies him as little Mr. Bear. You can see here that false negatives don't exist on my custom model for the various animals. Interestingly enough, at this zoom, the table is registered as a laptop for the pre-trained model, which was an interesting observation. Of note also, you can see that the frames per second is typically higher on my model. One of my goals for the project was to detect little Mr. Bear in a pile of stuffed animals, as that's usually the case in which he gets lost the most. You can see here, as long as a significant portion of his body is exposed, the model is able to detect him. Cup in front of him to see just how far we can. There's the boundary on that side, and on this one, obscure looks like some of his face, and they'll still. There were several that I learned during the evolution of training and retraining the model. Test harness was the easy part. The code that goes along with this is minuscule in comparison to the time to prepare a data set, train the model. Overall, what I learned is that the data really matters the most. The model accuracy is highly dependent on data, in this case the amount of pictures that you feed it for training. Epochs are useful with larger sets, however have diminishing returns with smaller sets. In terms of project enjoyment, I really enjoyed working through this project. I think my failures through the 3 to 4 iterations of preparing data training sets, seeing how it shook out at the end really helped me to learn a lot about computer vision, model generation using TensorRT and PyTorch. Overall, I would say it's a good experience, and learning through failure was more valuable to me than success that I had at the end. There are several areas in which future enhancements could be made to this project. The model could be enhanced. There's always room for improvement. Adding more to that will make it more resilient, as proven in the course of this project. The test harness could be adjusted to ingest a real-time streaming protocol. This would enable the happen from a networked IP camera. Third area for improvement would be a user interface for ease of use. The likely candidates for users are my wife and daughters. They would much prefer to go to a web page that could be hosted by the Jetson Nano to detect the bear in the room.